Hi, my name is Virapat Pimanekha. This video presentation is talk about Chapter 4, Network Layer. So we have introduction, network layer protocols, unicast routing and multicast routing, and next generation IP. So this is how network layer works. So it go like this. So network layer service. Before discussing the network layer in the internet today, let's briefly discuss the network layer services that, in general, are expected from a network layer protocol. So it has packetizing, routing, forwarding, alert control, flow control, congestion control, quality of service, and security. So this is a forwarding process. Packet switching. From the discussion of routing and forwarding in the previous section, we infer that a kind of switching occurs at the network layer. A router, in fact, is a switch that creates a connection between an input port and output port, or a set of output ports, just as an electrical switch connects the input to the output to let electricity flow. Switching techniques: circuit switching and packet switching. Circuit switching at the physical layer and packet switching at the network layer. The connection device in a packet switch network designed to route the packets to the final destination. Two different approaches to route the packets: datagram approach and virtual circuit approach. Datagram approach, virtual circuit approach, setup phase, data transfer phase, and teardown phase. A connectionless packet switch network. Each packet independently having no relationship to any other packet. The network layer delivery of a packet from the source to the destination. The packets in a message may or may not travel the same path to their destination, like this. Forwarding process in a router when used in connectionless network. Each packet is routed based on the information contained in its header, source and destination addresses. The destination addresses is where it should go. The source address where it comes from. Error message. A virtual circuit packet switch network. Virtual circuit approach is connection-oriented service. Before send, a virtual connection should be set up to define the path for the datagrams. After connection setup, the datagram can follow the same path. The packet, the source and the destination addresses a flow label. A flow label is a virtual circuit identifier. So it has a path to go. Forwarding process in a router when used in a virtual circuit network. In the virtual circuit approach, the forwarding decision based on the value of the label or virtual circuit identifier of the packet. Sending request packet in a virtual circuit network. Setup phase. A router creates an entry for a virtual circuit to auxiliary packet exchange, the request packet and the acknowledgement packet. Sending acknowledgement in a virtual circuit network. Acknowledgement packet complete the entries in the switching tables. Flow of one packet in an established virtual circuit. Like this. Network layer performance. The upper layer protocols that use the service of the network layer expect to receive an ideal service, but the network layer is not perfect. The performance of a network can be measured in terms of delay, throughput, and packet loss. We first define these three terms in a packet switch network before we discuss their effects on performance. Delay. So for delay, it has transmission delay, propagation delay, processing delay, queuing delay, and total delay. Throughput. Throughput is the number of bits passing through the point in a second. Packet loss. Throughput in a path with three links in a series. In a path from source to destination, a packet may pass through several links or networks, each with a different transmission rate. How then can we determine the throughput of the whole path? This is the bottleneck, a path through the internet backbone. The actual situation in the internet through access networks and the internet backbone, the minimum of TR1 and TR2. Effect of throughput in share links. A router may collect the flow from several sources or distribute the flow between several sources. The transmission rate of the link between the two routers is shared between the flows. The transmission rate of the main link in the calculation of the throughput only 200 kilobytes because the link is shared between three paths. Network layer congestion. In Chapter 3, we discuss congestion at the transport layer. Although congestion at the network layer is not explicitly addressed in the Internet model, the study of congestion at this layer may help us to better understand the cause of congestion at the transport layer and find possible remedies to be used at the network layer. Congestion at the network layer is related to two issues: throughput and delay. Congestion control. So it has open loop congestion control or prevention. And for open loop, it has retransmission policy, window policy, acknowledgement policy, discarding policy, and admission policy. And for congestion control, it has closed loop congestion control or removal. So it has back pressure, show packet, implicit signaling, and explicit signaling. Back pressure method for alleviating congestion. The congested node stops receiving data from the immediate upstream node or nodes. A node-to-node congestion control that starts with a node and propagates in the opposite direction of the data flow to the source apply only to the virtual circuit networks, not datagram networks. The pressure on node 3 is moved backward to the source and remove the congestion. Show packet. A packet sent by a node to the source to inform it of congestion. The warning is from the router directly to the source station. The intermediate nodes are not warned. Example, ICMP. Structure of a router. We represented a router as a black box that accepts incoming packets from one of the input ports or interfaces, uses a forwarding table to find the output port from which the packet departs, and sends the packet from this output port. In this section, we open the black box and look inside. Component. So for a router component has input ports, output ports, routing processor, and switching fabrics. So and it has crossbar switch, banyan switch, and batch banyan switch. Input port. An input port performs the physical and link layer function of the router. The bits are constructed from the received signal. The packet is decapsulated from the frame, checked for errors, and discarded if corrupted. The packet is then ready to be processed by the network layer. Output port performs the same function as an input port, but in the reverse order, like this. Crossbar switch. A crossbar switch connects an input to an output in a grid, using electronic micro switches at each cross point. Banyan switch. A multi-stage switch with micro switches at each stage that route the packets based on the output port represented as a binary string, like this. For this example of routing in a banyan switch, n inputs and n outputs. Basher banyan switch. The problem with the banyan switch is the possibility of internal collisions, even not the same output port by sorting the arriving packets based on their destination port. The sorting switch uses hardware merging techniques. Another hardware module, a trap, prevents duplicate packets. Only one packet of only one packet for each destination is allowed at each tick. Thank you for watching.